All right, a couple examples of using combinations of two random variables here and calculating both the average and standard deviation of the combinations. Scenario one, a bakery uses a large machine to dispense frosting on cookies. The machine places 4 dots of frosting on each cookie with an average mass of 3 grams and a standard deviation of 0.25 grams per dot. Find the average and standard deviation of the mass of the different frostings on the cookies. I need to find the expected value of each of these different 4 dots. So that's the expected value of 1 dot plus the expected value of the next dot plus the expected value of the third dot plus the expected value of the fourth dot. Each of these dots are different random variables. They're different events. I place 1 dot at a time. The average mass of each dot is 3 grams with a standard deviation of 0.25 grams. Sometimes the dot might be underweight. Sometimes it might be overweight. Each dot is its own separate random variable. So this would be 3 plus 3 plus 3 plus 3 are 12 grams. I'd expect an average mass of 12 grams of frosting for the 4 dots of frosting on the cookie. Let's find the standard deviation in that average. Of course, with this standard deviation, I have to combine the variances. It's the variance of the first dot plus the variance of the second dot plus the variance of the third dot plus the variance of the fourth dot. I treat each of these different dots as their own separate event. Remember, for standard deviation, it's the variances that combine. I combine the variances, not the standard deviations. If the standard deviation is 0.25, the variance is 0.25 squared. So I have 0.25 squared 4 times. If I want to find the standard deviation, take the square root of that, because standard deviation is square roots of the variance. Take 4 times 0.25 squared. Square root of that is 0.5. We have an average mass of 12 grams for the frosting with a standard deviation of 0.5 grams of frosting for our distribution. All right, another scenario. An insurance company estimates it makes a profit of $300 on each policy written with a standard deviation of $4,000. The standard deviation is going to be very large in this case because they're either going to pay out nothing or a very large amount if the homeowner makes a claim. Most of the time they're going to pay nothing because there are no problems. The homeowner makes no policy claims. But in the case where we have floods or fire damage, etc., we're going to have significant damage and have to make a claim and pay out some money. So I have a wide variance in this scenario. Find the average and standard deviation if the company writes the following number of policies. So let's try a couple of different numbers here. Let's assume that they write out 2 policies. Each of these 2 policies are their own random variable. I have to treat them separately. The expected value would be the sum of the expected value of each of these 2 random variables. In other words, it's going to be $300 plus $300 or $600. Now, For the standard deviation, I have to combine the variances. The standard deviation is $4,000, so the variance is $4,000 squared. I treat each of these policies as two separate random variables. And then add them together. So this would be $4,000 squared plus $4,000 squared. Standard deviation is 4,000. The total variance is 4,000 squared. Of course, I want the standard deviation, so let's take square roots of that. Let's see here, 2 times 4,000 squared. Take square roots, and I get $5,056.85. $5,656.85. If I write out 5 policies, what is the standard deviation and expected value for the profit in writing out 5 policies? Well, the expected value would just be 5 times $300, which was the expected profit per policy, or $1,500. I'd expect an average profit of $1,500 by writing 5 policies. The variance of writing 5 policies would be 4,000 squared plus 4,000 squared, and so on 5 different times. In other words, 5 times 4,000 squared. Standard deviation of that is just square roots. $4,000 squared plus 4,000 squared plus 4,000 squared 5 times. In other words, it's 5 times 4,000 squared. Is $8,944.27. I'd expect an average profit of $1,500 with a standard deviation of $8,944.27 by writing 5 different policies.